CNC subprograms explained. Cut this gear in 22 lines of code, not 1300. Well, in reality, you can cut any number of teeth and any number of multiple passes in 22 lines of code. And we're going to show you how to do this in this video. Before we get started, please take a moment to like and subscribe. It's free and it'll help me out. Okay, let's get started right now. Warning, viewer discretion is advised. This video is made for apprentices and may contain scenes that are over-explained and may not be appropriate for your skill level. You can find a copy of this program in the video description below the video. Also, a major shout out to my collaborator Richard. Without him, this video would not have been possible. Here's what the last tooth looks like on the program. The camera works a little bit shaky, and it gets worse when you put it at 8 times the feed.
Okay, so this is a program that will rough the gear, and at the top we need a % sign, and that tells the computer when to where to upload the program from. So when you tell it to upload the program, it looks for a % sign at the top and at the bottom of the code, and anything below the % sign does not get reloaded or loaded up into the machine. So these are just notes that we put at the bottom of our program to help, like for edits, keeping control of edits that you make in a program. Then you have your program number and always some sort of description, and the machine will read that as it uploads it, and it'll show that in the description in the list of programs. It's always good to talk about what kind of material you're going to be using, and we're not using aluminum here. I believe we're using steel, but whatever the case may be, you can put that in there so that if the speed, so you can tell what the speeds and feeds were designed for. And we just have something very small here, who made the program, so you know who to go and consult later on if there's an issue, or to pat on the back that it's a personal program.
We don't need to worry about that.
That's right. It's always good, in my opinion, it is always good to put some sort of description for setting up or explanation of the program. Try to keep it brief, try to keep it concise, so that if you have to edit the program, if you have to set it up, whatever the case may be, that you have information there. And actually this, when we look at this, this is just an explanation of the program. This does not have any kind of setup information about where you should be setting up your cutter, your origin of your part. So that would be something that could be added here, or would show up on our setup sheet. Okay, now this is vital information because we're using subprograms here, and you'll see what happens in a minute. When we run this, that it repeats a lot of the cycles over and over again. So there's things like these L values, whereas when right here, this L value here can be altered to represent different changes in the teeth or in the part. Okay, so it's always good to have some sort of explanation. The next couple of lines are just our typical setup lines that you would see pretty much on any kind of CNC program, where it just tells the machine how to get started. It gives a starting location for X and Y, and because we're using the rotary head or the 4th axis, it gives an A value for the rotational degrees. And we have speeds here and direction of cutter. Then we can go right into line 7 here, and we see that we have it right away. It goes into a subprogram. So a subprogram is basically a program within a program. All this code is considered one program, and then you've got multiple programs inside of it. So you've got a 06001, 06002, and 06003. These are all different subprograms within. So the first thing that happens is that it's calling on 6003, and it's going to do it 8 times. That's what the L8 represents. It's going to repeat this subprogram 8 times in a row before it moves on to any other line of code. So we can look down at 6003, and we have to go way down to the bottom. And again, there's just a little note here about what this does, and it makes 1 tooth plus rotation. So this is going to actually do multiple passes to cut 1 tooth. And the first line of code that we see is another subprogram call. So 6001 is going to be repeated 13 times. So now we got to go up to 6001, and we can see that now it's going to, this is the code to mill 1 tooth on the part. And this is just code here for what the machine has to do. And it's going to do this 13 times before it moves on to the next line of code. And I'll run this very shortly and go through how we can see it all. So this is going to basically take 13 different depth passes on that first, to make that first tooth. Okay, and again, this comes into these notes if you look at them later on. So it's going to do this 13 times. When it's finished, it's going to say, okay, I've done this. So the machine keeps track of how many times it did this little mini program. When it's done the 13th time, it's going to go back and it's going to say, okay, this is done. Now what? And it's going to say, oh, now I got to go to 6002. And 6002 indexes to the next tooth. And this is basically very, just a couple lines of code to tell the machine. And then we see that the A is a rotation of the indexing head on the fourth axis, and it indexes 12.857, which was calculated based on the pitch of the gear teeth. And then it's going to move to a Y position, and it's finished. And now this program is finished, but it's only finished once. Like I said, it's actually going to do it 8 times. The 8 times represents 8 teeth. So when it's finished all of this once, it doesn't go back up to here, up to this line of code. It says, no, I got to do it all over again. So now it says, okay, now that I've rotated, this program rotates the part. Now I got to make 13 depth passes on the next tooth. So it does 6001 over again. Then it says, okay, I'm done 13 passes. Now I got to do the next subprogram, and all this one does is tell the part to move 12 degrees again. And then it says, okay, now I'm done 2 passes of that. So it says I got more to go. So it's going to do now 13 depth passes on the part again, and so on. So you're actually saving a lot of code. Your program would be extremely long, like thousands of lines long, perhaps, to do all this without subprograms. But subprograms allow you to bounce back and forth between subprograms to get this all finished. Okay, so I'm just going to do a little step through for now, and we can show you what's happening here. So I'm just going to do from the top of the program here. I'm going to just do a step through for now, step forward, just at the beginning here. So we've done all these lines of code now, and we're just going to step forward. It goes into 6001 because at first we told it to go to 6003, and it did. And the first thing 6003 does is say go to 6001. So this is actually our first move, and it's just going to go through 6001, and you can see on the picture over here on the right what's happening, and it's just going to keep on making passes. And if I go into top view here, perhaps, this would be looking down at the part, and all you're doing now is you're making, you can see here, we're just making these cuts. If I back out a little bit further here, it's just making, and every time it goes deeper. And when the time I'm all done, there should be 13 lines there.
So our blue line's representing a rapid move, right?
That's right. Any blue dashed line is a rapid in this software, and any solid white line is a feed motion in a linear.
So how did we get it to feed in the 20 thou every time it repeats itself?
We did that. where it'll be in here. So this is our Y, 20 thou here. Okay. So to explain this is a little bit trickier because this switches between G90 and 91. But basically, G91 is incremental programming. So wherever you are is a 0, and we're telling it, in this case, to move in 20 thou. So what happens if we were to, let me just reset the program for a minute and run it again for a minute, and I'll just kind of explain every line of code here. So this one is telling the machine to move the cutter in 20 thou from the original cut. Okay, and then it goes, it's going to feed in towards the part. So the part is over here, in this area here, and the machine's going to feed the cutter in and then cut across. So this is the cut across, and then it's going to pull out. It's going to wrap it back to our starting position, and it's going to move in 20 thou more. So what's happening down here is that this is going to move every time 20 thou. So there's 20 thou here. Okay. And so it's basically every pass is moving 1.625, in our case, up and down along the y-axis. Okay, so from this line here to this back line here is 1.625 long, this y motion. And it means that from this line to this line is also 1.625. So that 20 thou is being moved in here. That is our depth of cut. So if we had a really good strong setup and we were perhaps using aluminum, we would say, I don't need 20 thou, I want to do a 40 thou cut. So all you'd have to do is change this math, change that to 40 thou, but then we wouldn't have to do this 13 times, we'd have to do it like 6 times. So actually you'd have to come up with some multiplier here to do this correctly. Okay, so in a note up here, it says how to change the depth of passes. So there's 20 thou by 13 passes is 260 thou deep. So if you wanted to do this in less passes, you'd have to divide, you know, a certain depth of cut to come up with equal number of passes here.
So if we wanted to do 26 passes, so we would turn around, and then it wouldn't be 2 thou, it would be 10 thou then.
That's right. It wouldn't be 20,
routes.
it would be 10. That's right.
Then if we wanted to do it in less passes, we would just divide it out.
Right. But if we did it in 26 passes, don't forget, we have to tell the program to repeat 26 times. Otherwise, you're only going half as deep. Okay? So there is, I mean, and that's where the understanding of how a subprogram works is very important. And that's why you make explanations on here. Okay? Because even for a person who made this program, you go back to this program, you know, 3 or 4 months later, and you have to edit it, and you're going, oh no, wait, I don't know how to do this anymore. Let's figure this out again, and you have to start all over again, right?
If that note wasn't in there, even 3 days later, I wouldn't remember.
You know what? And it's no shame to say that because it's true. It's true. Like you wouldn't remember, like especially if you're a programmer and you're going, well, you know, like that's 5 programs ago. I don't know what the heck I did, you know, 2 days ago. So always make sure you put notes to yourself. This is to stop you from looking dumb later or forgetful, right? Because they take old people like me and they bring them out to the field and shoot them when they can't remember what they programmed anymore. Okay. So I mean, you wanna, you know, just keep track. And it's the same down here at the very bottom. Again, these notes do not even show up in the program once you upload it to the machine, because the machine only uploads what's ever between those % signs. Okay. So in reality, as a matter of fact, you didn't even need to put these parentheses here because the machine doesn't read that. They're just there because of the same format. So the subprogram, you could never edit a program if it was done longhand. Okay, it would take you forever to edit a program if it was done without using subprograms. Okay. I believe I have one here. I don't know what this one is. Yeah, so even this is a slightly different. This was made from MCAM, and you can see we have arcs instead of a straight line, but we got rid of the arcs in our program because they didn't need to be there. It was just extra motion. So this is how MCAM would put out a program, and you can see there's many lines here. Okay,
And that's only one tooth.
well, and then apparently I put a subprogram in here to index it, so this would do all of them. Okay. Now the problem is here that if I wanted to take it, you asked the question, what if I wanted to do this in 26 passes? You would have to double up. You would have to make, twice 152 lines. So it would be like 300 lines of code.
Yeah, but then again, if we were just doing this straight up without using subprograms, that would be 152 times 8.
Well, this program does all 8 as well. Oh, if you don't do any subprograms, you're absolutely right. So it would be because this one does it 8 times.
So
okay.
That's a program well over 1,200 lines, and we knocked it down to a program just under or over 20 lines.
Yeah, so it's 10 lines here, 6 and 3 is 9. And another 3 is 12. So that's 22 lines of code.
Yeah.
From take a line.
Way over 1,200.
Right. So even this has got two subprograms, right? So again, we're doing L8 here, and that's to do 8 teeth. Right? So if I wanted to change to 10 thou cuts, I would have to try to find my, like where that line of code is that tells it to go in from the previous line, and I'd have to edit that. So this would make it very difficult. I won't say impossible, but very, very difficult to actually do edits here. Whereas if you go over to the subprogram, between the fact of knowing how a subprogram works and the notes that you leave as little breadcrumbs, then you could edit this program to do pretty much anything you wanted to with it, for gear cutting. You could tell it to go deeper cuts, lesser cuts, more teeth, less teeth, different angles. So again, notes here, for how, maybe you're going to do 6 teeth on that arc. Then all you got to do is the math to figure out the pitch between those teeth and substitute for the 12.857. And you could do anything here. So, this is the beauty of a subprogram. I'm a big fan of them, but you got to be you have to be able to understand how a program tracks. And this can get confusing. We've got 3 different subprograms here. Okay, so if we run this in somewhat real time, and you can see what's happening over here, it's just going back and forth, and it's going to do this 13 passes. And then it's going to quickly go to here, back to here, and then back up.
There you go. Just did it.
Yeah. So and because we're rotating the part, you don't see any difference. It's just it just rotated apart. Oops. Sorry. We're rotating apart along our x-axis. So the center of the part is right here, if I recall correctly, the way we had it set up. So the part is actually rotating. We don't see that here. But it would be more like, looking at it, from the side of the machine, the part would be here, and it's just going to rotate down every time, index 12 degrees every time around, and it does the same passes here. So that's the subprogram, and it seems to work pretty well. It is highly editable. So you can actually make it do anything you want to. So how's that for an explanation?
Excellent. How about the finishing program?
How about the finishing program?
Yep.
The finishing program is another program here. So this is for roughing, and again, I'm a big fan, a big believer, and any machinist should be, of roughing all your work first, whenever possible, to relieve the stress, to change tools to a finishing tool later on if you wish. And the finishing program is again subprograms, and you can see here that we just decided to use slightly different format here. We have, if we look at this here, we have 6004, and it calls on that, and it's just that 6004 is the finished pass of one tooth. Then we tell it to index and then run it again. So all we're doing is this one line of code here is replacing multiple times of having to type that code in or to do that code. So each one of these here, if I wanted to not use a subprogram, I would have to put this, 5 lines of code or 4 lines of code. I would have to put that in every time you see this line or this line or this line. And you might ask, why did I use 6004? Well, because we could use any number we wanted to, but we would not want to use the same number as previously used, because these programs could potentially be loaded onto the machine at the same time. And if we were to call this subprogram 6001 again, for example, then they would want to overwrite the 6001 that was over here. Then that would be chaos.
You want to go through this program step by step and explain how the subprogram works and how it gets called up?
Sure. So again, we have our starting lines of code, and they're pretty much the same. We're running the same RPM here. We have the same starting location pretty much. And basically, after the program moves in Z to the right location, we're right away calling 6004, and 6004 says to come towards the part. It's not touching the part yet, and then feed across the part. So in here, there would be contact with the part, and outside, and then out of contact again, and then go back, and then move across again. So you could actually have this line of code. You could have a G00 here, a rapid, okay? Or you could just increase the feed rate here just to save a bit of time. And you could do the same thing back here with this program. This line could have been a rapid. The only reason we didn't was just so that, don't forget, in our setup, the part is here, we got our chuck here, and it's really scary to see things moving very fast when you're in close quarters here. But I mean, really, once the program works, there's no reason why you can't make that a rapid or a high feed rate.
Also a one-off part too.
That's right. Yeah. So time it wasn't about a time thing, but really, I mean, you could change that, and maybe it should be changed, or maybe even, so for example, just on this program to save a bit of time, and maybe you don't want to wrap it because it is scary to see things moving very fast. What you could do is you could instead, you're already in G01, which is a feed motion. You could just add a feed rate here of say 300 RPM or inches per minute. And it just feeds very fast out, okay? The only thing is that what you need to do here then, well, it's already here. You want to put a feed rate across. Okay, so actually, again, to make this more efficient, we could do this. The only time, sorry, I lost my mouse there for a minute. The only time you actually have to feed at 8 inches per minute is when you're actually making your cut across, which is this line of code here, which is this. So this feed rate in could also be a feed of 300 inches per minute.
Now you're going to scare them.
Well, I mean, 300 is still fairly slow by today's standards, but it, because rapid is 2,000 inches per minute, right, or 1,000 inches per minute, depending on which machine you have. So 300 is still, slow enough to be able to feed hold if something seems to be going wrong, but fast enough so that you're not sitting around wanting to drink a beer while waiting for the code to finish. Okay, so I mean, right there, that's a time saver right there. If you look at how many inches we're moving here,
That's
so
probably
we're moving,
25% of the time in the program.
yeah. So yeah, because it's actually 1/3 of the program. We've just increased our, because there's 4 lines of code going around, right? So you're right.
Yep.
So that's 25%. This is 25%. This is a 3.5-inch line almost. Times 2 is 7 inches, and we just told it to go from 8 inches per minute. So that these 2 lines here take approximately a minute to do. Approximately about 50 seconds or whatever. Okay, at 8 inches per minute. But now at 300 inches per minute, well, I'm not even going to bother with the math, but it's you can see it's a big time saver just by changing that. Okay, so and here again, like what I would do here is I would maybe make a note down here now, because this is a good change. This is a positive change. And what I could say, I would say edited feed rates. Oops. In for advance and retract. Motions. I'll just go to the next line. From 8 inches per minute to 300 inches per minute. And I'm going to say what line numbers they are. I'm going to say 6001 N1 and N3. There. And I'll just save that. So now you've got a program now that has cut down your time. And honestly, you could do the same thing here very easily, and well worthwhile the change. Right? So you just go mill 1 tooth. So here's restart. This is our feed in. So all you'd have to do is put a different feed rate here now. Feed 300. Feed 8. Feed of 8. And then feed of 300. Okay. Mm-hmm. And then I would put a note down here too. I could actually just take this note here, copy it, and paste it at the bottom. And the line numbers are different. 6001, 2, and 4. And we've got a program. And again, the math, you can calculate the time savings and then split it with your students on how much money you just saved the company. Right? And then the next guy will come along and say, hey, instead of 300, why don't we do 2,000 and do a rapid? So, and you saw how easy that was now. So you can imagine here, I've got a subprogram. It does this program how many times? Okay, so it does this program, it's this program, 6001. It does it 13 times, times 8. 13 times 8 times, whatever that is. So it's almost 130 times.
Yep.
Okay, so you would have to make not 130 edits, 260, because we edited 2 different lines of code.
Yep.
Right. So we edited this line and this line to find a program. Even this subprogram, there's probably about 30 edits or more here, 50 edits maybe. I don't know. That you'd have to find every feed rate or add a feed rate to it. That already, I just proved the usefulness of a subprogram right there. So So that's all I got to say about that.
Cool. So back to the nuts and bolts of it. Every time you see a G98, that's calling up a program.
M98, yes.
Oh, M98. So every
Yes.
time you see an M98, it's calling up a program, and then it tells you what program to it. And then at the end, when it says M99, it sends you back to the original spot where you were.
Right. M98 says to call on this program. So the computer looks for this program as an O value. So O6003 is down here. And then M99 says, okay, the program's done. Go back to where you came from. But in this case, because there's an L8, the machine remembers that. The machine will say, oh, I got to do this 8 times. I only did it once. And you can actually see it count on the controller, on the CNC controller. You can see, so later, you can say, oh, it's almost lunchtime. How many times have I repeated this program already? And it's, it's almost done.
And it'll repeat any program, right? If there's a can cycle inside that does drilling or pocketing, it'll repeat that as well?
Yes. Yeah. Now you have to be careful how you use it, but yes, the answer is yes. Or it'll actually, you can use an L value in an incremental section. If you have like 10 holes in a row to drill and they're all 5/8 apart, you can tell it to move G91 incrementally 5/8 and do it whatever it was, 12 times or whatever, and it'll jump 12 times. So one line of code could make all 12 holes using the L8 value.
Excellent. Thank you, Richard. I much appreciate your help pointing that out and explaining it to us.
No problem.
Excellent. Glad to see that you enjoyed the video. This wouldn't have been possible without my collaborator, Richard. Much appreciated. If you have any comments or questions, leave them in the comments section below. If you want to see other great videos, check out my YouTube channel, Shop in Math. Don't forget to like and subscribe. It's free and it'll help me out. All you have to do is click on the icon of my face and I'll do the rest. Thanks for watching the video. Have a great night.